Stop attackers from domain credential theft and lateral movement with a 99% success rate by using artificial intelligence to control the attacker's perception of the environment. Javelin Networks is the world's first endpoint intrusion containment platform to protect domain networks. Javelin detects targeted attacks and breaches by obfuscating Active Directory, domain controllers, domain identities, domain credentials, and all domain resources. It only takes one compromised machine to jeopardize the entire organization. Don't be a victim. Visit javelin-networks.com and request a demo of AD Protect today. IT Pro TV, binge-worthy learning for IT teams. Why is it binge-worthy? It's learning presented in an engaging and entertaining talk show format that beats voice-over PowerPoint snooze fests. Watch over 3,300 hours of content in their on-demand library on your desktop, on the go, or in the comfort of your own living room. IT Pro TV is IT training you and your team actually want to watch, which means a better return on your learning investment. Get started with IT Pro TV for Teams by visiting itpro.tv/Security Weekly and start a 7-day free trial and get 30% off standard or premium IT Pro TV memberships using the code SECWeekly30. The greatest threat to businesses today isn't the outsider trying to get in. It's the people you trust, the ones who already have the keys, your employees, your contractors, and privileged users. 60% of online attacks are carried out by insiders. To stop these insider threats, you need to see what users are doing before an incident occurs. ObserveIT combats insider threats by detecting risk activity, investigating in minutes, effectively responding, and stopping data lost. Give it a test drive at observeit.com/Security Weekly. Are you overwhelmed by the sheer volume and noise of alerts? Struggling to define priority while searching for context? Wondering why we're still playing telephone while attackers invest in technology to ease their efforts? It's time to make a stand and demand a different approach. Imagine spending your day doing the valuable work you crave. It's possible today with ServiceNow. Visit servicenow.com/SOAR, that's SOAR, to get more information and make the case for your better approach to security orchestration and automation. Welcome back, everyone, to Enterprise Security Weekly. I'm here, of course, with John Strand. Momentarily, John's going to run soon, but I'd like to introduce Guy Franco from Javelin Networks, who will be giving a demonstration today on some Active Directory stuff. Guy, welcome to the show.
Hey, well, thank you very much, Paul.
We worked through some technical difficulties, but we're ready now. So, Guy, what are you going to be speaking about today?
So today I'm going to show you basically what happens after attackers has gained the highest privileges and what exactly they can do in order to basically hide privileges for a long period of time that will help them sustain in the organization for years and years. I'll give you also some stuff to look at on how exactly to find out you have those persistence in your ID. Some of them are really hard to find, but some of them have some good indication. And I think this is what I'm going to focus on the talk today.
Yeah, John and I were reading the description guide, and you talked about admin SD holder and SD prop. Maybe set the stage for us on what those things are.
Sure, of course. So this basically we can call it the most basic kind of persistent. The way this persistent works is by actually modifying high privilege groups. So admin SD holder is pretty much an ACL that tells who has the permission to change high privilege groups and who doesn't. Now, what we can do with this kind of ACL is give special permissions to user accounts to either be the owner of this ACL or to be able to change this ACL. And we can then give specific user accounts very high permissions, but by itself, this user won't have any permission, or he won't be in any sort of group that would indicate that he has high privileges. So this is a pretty cool way to hide privileges, and you can do some pretty cool stuff around it. For example, you can create something called just-in-time admin. What it means is that you can hide completely your privileges, but every time you need admin access in very easy method, you can give yourself an admin access for only a very short amount of time and for a certain amount of actions, and then this basically admin will get deleted, leaving zero traces. So this stuff is can be done by manipulating the admin SD holder. I was planning actually to show you a few demos around it. So, oh, okay.
Yeah. Now, John, is this something that you're using in your pen test today, or something you're familiar with?
For a lot of the persistent mechanisms that we're running, they're a little bit different. They're far more short term, and this gets into one of the differentiators between a network penetration test or even a red team, and somebody that's trying to stay on your network for a good 6 months or longer. So this technique I think is important, and I also think it's interesting because it's usually not something that is tested very often by a lot of security testing companies.
Beautiful, perfect. Well, not so beautiful if you're trying to defend the network, but beautiful if you're an attacker.
Yeah. So also I'll talk about few stuff that people may already know, like passwords that never expires. So this is something that is fairly well known, and now basically IT departments do try to get some visibility around user accounts that doesn't need to reset the password, which means that necessarily if an attacker gets a user like this, he will be able to reuse it again and again without anyone that can actually stop it, without any sort of password rotation. But there is also something that not many people know, that you can gain even much better kind of credential persistency by requiring a smart card from a certain user. What it will actually do is create a persistent for the hash of the password of this user, because this is how smart card works in a domain environment. And basically, if I set this flag, I will be able to use the same hash over and over again for years without anything that will be able to reset the password. So this is what we're going to see in the demo. And then if we'll have some more time, I'll talk more about persistency that we can create actually on the Active Directory itself. So I'm not sure how I can share my screen. Is it possible through this?
They might have to, if you share your screen, they might have to just switch to it.
Okay, because I don't see the icon for screen sharing.
In Skype, it's actually under call. If you go call and you drop down, you can do share screens. So in Skype, just do call, share screens, and then that should work.
Yeah.
It's not an icon.
I can see it. Okay.
So
can you see my screen now?
There we go. All right, and with that, my job here is done. I'll talk to you guys later.
Have a good one.
Great.
Yeah, so we can see your screen. Awesome.
Yeah, great. So let's dive into what exactly I wanted to show you. So right now we can see here, I'm connected to a machine that basically sits in a domain environment. We can see that the user account I'm currently connected with, his name is Guy Test, and we can see that currently I'm a regular domain user. I also have high privilege accounts in my disposal, and we will use this account in order to create persistent for this user account, the Guy Test. So let's see how it works. So what I'm going to do right now is authenticate with the high privilege account. And this basically will allow me to edit some stuff on the Active Directory that would apparently allow me to actually create persistency in many ways. So for now, what I'll do is I'll show you how I can basically manipulate the admin SD holder and how actually it affects the editing of the high privilege accounts. So we can actually see here, if I connect to the DC here. I'll go through basically a container called system, and we can see another container called admin SD holder. Now, if I click properties on it, I'll be able to see the security descriptor basically of the of this object, and any user that I'll be adding here will basically get the privileges to edit the group according to what I select here. So let's say, for example, I want to add guy test here to the security ACL, and I'll give it full control. What it will actually do is we won't see any sort of changes regarding the this user account. It will still be a domain user. Now, if I'll open also DSA, the directory services, and I'll go to the and I'll find this user. We will see here that basically still has the same privileges, but now when I'll try to basically edit the groups of the high privilege accounts, I'll be able to do this. And it will only happen when something else basically works on the background on the DC, something that is called the SD prop. So SD prop is basically a process that runs on DC every hour and basically update the ACL of the admin SD holder across all the high privilege account, all the high privilege groups. So right now, the SD prop hasn't started yet, meaning that if I'll try now, one second. If I'll try now to go into, for example, the domain admins group, and I go to the security ACL here, I still won't be able to see this user account. But now what I'll do is basically force the SD prop to work now, which should basically get this ACL synced up, which would allow me basically to edit this group. So I'll connect to this DC. To the bind. Now I'll run the SD prop. Okay, sorry.
Now, Guy, to run the SD prop, do you already require a higher level of privilege to do that?
Yes. So I'll do it from the DC because here I don't have the privilege from Guy test, but here on the DC, basically I'll open the LDP and do it in the same way.
So this is more about hiding than it is gaining access.
Exactly.
Gotcha.
Exactly. So after I gain the high privilege account, basically I can do this kind of games in order to persist for a very long time. So I'll do it again from the DC itself, because here I have the right permission. Oh, that's weird. 1 second. Let's try again. Okay, so now we can see it actually worked. I'll just keep the DC updated across all the domain controllers in the environment. And basically now when I'll go back to the original machine, now I should be able to edit this group using the permissions that I have now. So what I can do now, you can see I'm still a regular user account, but 1 second.
So essentially, you're going to appear like you're a regular user account, except you have kind of hidden higher privileges.
Exactly. So here, what? Oops. I need to open a PowerShell and run this command again. This will basically add the guy test user to the domain admins. We can see it actually worked. Now, if I'll do the domain admins enumeration, we should see basically that the guy test account is now part of the domain admin. Now again, what I can do is basically run as again with this user account. Run as. We can see now I have a ticket with this user. Should have I privilege. So we can see now I actually browsing through the C directory of the domain controller. And at this point, while I got this access, what I can do is remove all the tracing that I actually added a user to the domain admins group and still have the right amount of access to continue work from this shell. So basically now I can remove this user. I can change again the admin SD holder and basically still operate from the same shell. So the only thing basically that I need to keep operate the admin SD holder is to either has the right permission or full control access to edit the admin SD holder, or the ability to have basically to be the owner of the admin SD holder, and then I'll be able to get the admin whenever I need it without actually alerting that a new user was added to domain admins, because I only do it for a split second, then I remove it, but stay on the same shell, which basically gives me the ability to persist as a domain admin without being on this group. So once again, if I enumerate domain admins, I won't see a guy test, and I'll still be able to perform any sort of high privileges operation as long as I'm connected with this shell. So basically, this is what we call just-in-time admin. Whenever I need the admin, I'm doing these tricks with the admin SD holder. It could be like even a small script that doing it for a few milliseconds and give me back a shell with basically privileged access without almost changing the AD itself. We also mentioned basically that I can persist, for example, if I want to persist the guy test account for a long period of time, what I can actually do is I'll go back to the domain controller where I have a domain admin. What I can do is open here the DSA. Go to the guy test, and in this account I'll be able to select either the password never expired, meaning this user account won't be like no one will tell him to reset the password or retake the password, or I can do something even stronger and select the smart card is required for interactive login. If I'll apply it, basically what it means is that even if the user will try to reset the password, if I still got the hash, I will be able to use the same hash over and over again, even if the user changed the password, just because I checked this this kind of attribute, which called the smart card login.
So you're basically reusing the hash that's associated with the smart card.
Exactly. But still, you can still, if you're auditing your Active Directory, you can still look for these accounts. Most of the people aren't really aware that using the smart card actually allows you to reuse credentials over and over again. But using basically simple queries, you can query for all the user accounts basically that has this kind of attribute on. So 1 second, I'll just need to resync the directory. And running the query again, we can see that basically guy test as the basically the user control. That means that it can log on with a smart card. So you can still see these user accounts, and it's very important to audit them and understand if this user account really log on with a smart card or not. If they are not logging in with a smart card, this is a very big indication that basically there is some kind of persistency around this user. So this is a fairly basic persistency attack. almost anyone can do it. You don't really need any technical knowledge to do this kind of stuff, and it could be very powerful. But we can even do more cool stuff than that. So another example is basically I can hide high privileged accounts behind regular user account. Okay, and the way it works is with some kind of attribute called SID history. So basically, every user in the directory server service has a unique identifier which called SID. Now the SID part, if I do get AD user, just to show you. Oops. We can see that this is the SID of the user account guy test. And by doing manipulation on the object of guy test, I'll be able to add another privileged user behind it and hiding the real privileges of this user account. So let's see it in action. What I need is a little hacking around the DC in order to obtain it. So I have on the DC here basically a piece of Mimikatz, which I will run. Okay, and now what I will do is something called basically patching of the SAD. And now what I can do is basically add different SAD to the same account guy test. Okay, so the SAD I will add is the SAD of one of the privileged accounts. So let's see what we can do here. So let's open PowerShell. And get AD user for one of the admins. And we can see that the SAD of this user account is this one. When I run this command, basically it will patch the guy test and add the SAD I told him into the SAD history. Now, practically what happened is every authentication attempt with the DC actually check if there are other user accounts that exist in the SAD history. The reason it actually exists is whenever you combine basically domains, you make migration between one domain to another domain. The new user account in the new domain get the old SAD from the old domain in order to keep the same amount of privileges. But I can basically change it into my favor by hiding high privilege accounts from the same domain into a low privilege account on the current domain. So practically now we can see that I'm logged in as guy user. Guy user, and sorry, guy test, and we can see I'm still a domain user, but behind my user still runs the NYC admin, which is saved inside the SAD history. So right now, for example, if I try to do privileges actions, for example, browsing again into the directory service. 1 second, I might need to replicate it again. Sorry. Okay, so now the new privileges should work. Oops. Okay, I'll check it again. It might need to do a reboot, or I had a mistake with SID, but in any case, this is also a good way to hide persistency by hiding a high privilege account behind a low privilege account. Another cool thing you can actually do is add special privileges that not really many people check. For example, replication. Replication is something that not many people really know what you can actually do with it, but using replication, you can basically take every hash from every domain controller into your own machine. It's very easy to do that, and all you need to do is go into the ACL of the actual Active Directory of the actual domain, and basically allow it to and give special permission, for example, to the guy test. To replicate. Now, these permissions are special permissions that usually never been checked. But when I give them this user account permission to basically replicate, what this user account now can actually do is get any accounts you want from the Active Directory by syncing with it. So a good method to do it is, again, by using Mimikatz. It has something called DC sync. So if I open Mimikatz now, oops. If I open Mimikatz here, and one second, I'll copy the command for DC sync. Basically, what it will do is try to sync with the Active Directory and basically get the user account and sync the user account I'm telling you. So right now I'm syncing the NYC admin. We can see the Active Directory actually accepted because I have the right privileges to create replication, and we can see it actually replicate into our console the hashes of the password that this user account actually uses. Another useful thing to do is to basically sync the curb TGT. So if you remember on the last call that we had together, I actually showed you what is the curb TGT and what you can actually do with it. So one of the cool persistency that you can do with curb TGT is create a golden ticket. So the idea behind golden ticket, it manipulates how the Kerberos ticketing is working on the machine. Basically, every ticket that the Active Directory creates is encrypted using the curb TGT account. So if I got the hash for the curb TGT, what it means is that necessarily I can identify as any user in the domain and get any kind of privileges I want with very easy steps. All I need to do is to take the hash of the curb TGT, and I'll save it here. I'll copy the command to basically use it in Mimikatz. So we can see the command is Kerberos golden. What it asks for is the curb TGT hash. We need to tell it what domain to log in. And we will also tell it to what kind of user account to be looked at. So let's call it the NYC admin because we know this admin exists. By the way, it can be any sort of user you want. So if you want to call it anything in the world, it will still work because the Active Directory doesn't really verify if the name of the user exists in his directory. What it checks is only if the ticket is encrypted using the curb TGT hash. If so, then it will allow you basically to gain any ticket you want. So it doesn't really matter what kind of user you enter. So if I'll do this kind of command and run it here. Sorry, I missed the SID. So the SID, I'll get the same SID as the NYC admin. Just copy here the SID. Run again the command. And we can see here it actually created a ticket and saved it into the hard drive. Now I can take this ticket and use it in any machine in the network I want. Basically, I can inject this ticket to any session I want. and automatically I'll gain a domain admin. The reason I'll get a domain admin is because I added that this user account is also a member of the domain admin group. 513 is a default group in the Active Directory, which is the domain admins. Now, what I'll be able to do is to inject this ticket into memory. And open a command line, command shell. We'll be able to see this ticket in memory. We can see this ticket is valid for 10 years, starting from 2018 and ends up in 2028. So practically, I can use this ticket for 10 years, meaning I'll be able to authenticate with any user I want for 10 years without anyone knowing about it. So right now, because I'm a member of the domain admin, I'll be able again to go through the Active Directory and gain privileges. Not sure what happened, but in any case, we can see that it actually gets tickets from the Kerberos, and everything seems to work. Meaning, it was able to actually emulate the faking of the Kerb TGT. So this is also a very known vulnerability in Kerberos. And basically, golden ticket is something that is almost impossible to find. It looks like a regular user authentication. Practically, the only way to ensure you don't have golden ticket is reset the Kerb TGT account at least twice a year to make sure that if someone stole it already, at least you reset the Kerb TGT and you can't use again the golden ticket he created for him. Great. So for the last part, what I'll show you here is some source of persistency that is going to stay on the actual domain controller. And we won't use basically any sort of privileges hidden in other users or stuff like that. We will create basically persistency on the DC itself. So there are multiple ways to do that. One of them is very well known. It's called the skeleton key. So I'm not sure if you heard about it, but it was like a big stuff that Dell actually discovered a couple of years ago. What the skeleton key actually does, it can replace the authentication method using a third-party, basically username and password that you tell it to basically override every authentication on the network. So the way to do it is basically injecting some kind of malicious code into the DC process, in the LSAS process of the DC, and basically every authentication that comes, it will check first if a user account that you set out in the skeleton key is there. If you're authenticating with the skeleton key user, it will overpass the permission and give you whatever you want. So this is a very efficient way, basically, to persist for a long period of time by injecting skeleton key to the DC, for example, every time it rebooted. Another cool stuff we can actually do, I'll show it to you, is change something called the security provider of the Active Directory. So the basic idea around it is basically every third-party authentication. For example, if you want to add third-party authentication to the DC, you have to register it in the domain controller. The way to register it in the domain controller is into the security packages. Now, what you can do, you can actually sign up a new type of authentication that will be doing some bad stuff. So one example here we have is with Mimikatz. So Mimikatz can basically can either inject it into the memory, or you can add it manually through the regedit. So I'll open regedit, and we'll be able to see all the security providers of the DC here. It's under the current control set in LSA. There is something called security packages. So for now, we can see that the security packages are null. But I'll be able to add basically a DLL that will allow me to, for example, in Mimikatz case, we have something called Mimilib. Mimilib, what it will do, it will create a new security package that basically will write down every username and password that goes through this DC. So let's see it right now. I'll use it here. And basically, I'll be able to log any authentication either in the directory file or in the DC itself. And basically, it will allow me to see what user were logged in recently and what password did they use, which is very powerful stuff. So I'll copy the mimilib here. I'll also run here the MSSP. And basically now what we'll see is that any sort of new authentication that goes through this DC will basically be logged into a file here. So let's show one quick example here. Let's authenticate again with the guy test user. Oops. A second. I didn't allow, so use another user account. Okay. Okay, and we can see it actually logged in. It's logged the user account that got connected and the password he actually used. Now, in this example, it actually saves it inside the system32, but it's very easy to write your own kind of security provider and direct it to a network folder that will save each new login that goes through the network. So basically, this is another type of persistency. It's very hard to track it.
Yeah, that was my next question, Guy, was how do you discover this in your network?
So great question. So in this example, basically, if you inject it into memory, it's going to be hard. You can either inject it into memory or tell it to go through the boot from the security provider. So if you did an edit to the security provider, you can look if you can see some unknown libraries that are being loaded on the boot. If it's injected into the memory like I did right now with Mimikatz, the only way to discover it is by doing some kind of memory analysis to the DC to understand if there is something there. Regarding the stuff I showed you previously on the admin SD holder, it really requires you to make some kind of real-time analysis on the admin SD holder and who changed it in order to gain higher privileges. Also, you can look on who are the owner of the admin SD holder, which is also very important. So if I go back to the admin SD holder here, I'll be able to see that currently the owner of this admin SD holder is the domain admins. So if, for example, I'll change it to guy test, it will give me a permission to edit every time the ACL, but at the same time, it will show me something strange, that the ACL of the admin SD holder is being held by a user that is not the domain admin. So this also can give me indication that something wrong has happened.
So you really have to be looking for it.
Yes, yes. So some of them are kind of hard to find. Some of them you really need to know what you're looking for. In our solution, we have something that we call ADSS. That's basically creates some kind of attack simulation that runs every time. And basically checks either for vulnerabilities or persistency like that that people created, and can tell you if this persistency is new, what was the old value, and basically what this persistency means. So this practically allow us to tell you if there are changes in the Active Directory that may have been persistency. You can do this kind of stuff maybe by yourself, but it takes much more auditing. So I'm just giving here some ideas on how exactly you can do it.
Yeah, no, that's interesting because I know when we've spoken previously, you've talked about kind of those dark corners in Active Directory and how you developed AD Protect to kind of shed some light on those dark corners. And this is a great example of one of those dark corners within AD. So that's awesome.
Exactly.
Very good. Well, Guy, thank you so much. You can find out more at javelin-networks.com, the proud sponsor of the Security Weekly Network. Guy, thank you again.
Sure. Thank you, Paul.
And with that, we will conclude this episode of Enterprise Security Weekly. Thank you, everyone, for listening and watching. See you next time.